Hello everyone, my name is Devin Hunter, and today I want to talk to you all about the advantages and disadvantages of using ultrasonic sensor for a navigation task with an unmanned ground vehicle. Now with that being said, I know some of you may be wondering, what exactly is an unmanned ground vehicle? Well, below I included 3 different examples of unmanned ground vehicles that you can see in practice. One of the most common ones I'm sure that many of you have heard about is a self-driving commercial car, which essentially takes advantage of different deep learning algorithms in order to navigate through cities filled with different pedestrians and other cars. And one of the main issues that I saw with many of these different UGVs is that a lot of them require very high cost sensors in order to do all the different tasks that they're required to do in terms of navigation. And one of the main objectives of this experiment was for me to use a low cost sensor in order to try to accomplish some of those same navigation tasks. So going forward, the sensor that I actually chose to use was the ultrasonic sensor. And the way that the sensor actually is used is that essentially it shoots out small ultrasonic pulses. And if there's an object in front of the sensor, then the sound waves will bounce off of the object and go back to the received part of the sensor. And essentially this will calculate the DFC, or the distance from collision, between the object. And going forward, how I wanted to use this in the actual experiment is that I wanted to take this ultrasonic sensor and put it connected to a UGV and allow the UGV to go through a series of different navigation tasks, such as obstacle avoidance course, along with an autonomous parking course. And the methodology I proposed for the study was to first have the algorithm controlled UGV and the teleoperation control UGV. And just for those that don't quite understand, teleoperation is essentially a robot being controlled through human input, so basically like a remote control. So I was gonna have both of those robots go through various different navigation exercises. And from there, I was gonna execute a performance analysis on both the robots to determine which one is performing better in certain areas. And like I just said, with that, I was going to compare the scores and determine in what areas does the algorithm control robot do better, as good, or maybe even worse than the human control robot. So going forward, this is the actual robot that I use in the study, and the actual name of it is the Lego Smart Car Robot. And one thing to note about this actual robot is that it one limitation is that it actually it can house one ultrasonic sensor, and because that it can really only sense objects from the front of it or the peripheral, so it can't really sense things on the side of it or behind it. And because of that, there were issues in which it would hit objects that it wasn't even able to detect, as you guys will see later on. And this is the actual algorithm that I created for the navigation task. And this actual algorithm actually came from the company that created the robots for obstacle avoidance, but I actually put in my own little part into it, which was it also takes into account angular orientation of the robot. So based off the angular orientation, you'll do these different things to allow the robot to get through the obstacle course. And this is the actual first example in which I put the robot through the obstacle course, and here you guys can watch the video. This is the data that I actually collected while going through this obstacle course. So just so you guys know, the white data is for the data collected for the algorithm, and the blue data is the data collected for the humans. And as you can see, these are the different numbers of collisions and the actual time elapsed going through the experiment. And this is where the average scores, based off of my scoring system, that the human score and the algorithm score were able to show. And as you can see, the human performed better. Going past this, this was the actual parking task that I wanted to. And as you can see, at first the UGV hits the side, which is not obviously good. But as it goes forward, it's slowly correcting itself to make it more aligned. And these were just the average scores for the algorithm, along with the human user scores. And this was the performances, as we could see. And going past this, so as you can see, through both tests, the human users showed to perform better than the algorithm was capable of. However, there are different avenues that I could take going forward with this whole experiment. One including another ultrasonic sensor in order to better scan the environments. Another using different neural networks and also ROS in order to better picture the data. But yeah, so those could be the future works, and these are my references.